Hi, I want to talk about the organization of matter in the standard model of particles. All ordinary matter that we know about falls under two categories, what we call hadrons and what we call leptons. And the distinguishing feature between a hadron and a hadron is a particle that has a substructure still, and that substructure is made of quarks. Leptons are not made of quarks. They are, as best we can tell, fundamental particles. Now, leptons have three flavors. What we call electron leptons, muon leptons, and tau particle leptons. And electrons, muons, tau particles all have an electrical charge of -1 elementary charge. Now, in terms of mass, the electron has the smallest mass, the muon has a larger mass, the tau particle has an even larger mass. And all of those particles have a small, uncharged companion particle called a neutrino. And there's the electron neutrino, or just the regular neutrino, and that's the lowercase Greek letter nu. There's a muon neutrino, and there's a tauon neutrino. Neutrinos were some of the most recent particles to be discovered in sort of a new class of not subdivided stuff. By recent, they were first sort of really discovered and confirmed in the 30s, and we're still sort of probing and trying to better understand neutrinos because they're little, they're electrically neutral, they move at almost the speed of light, it seems, and they appear to change flavor as they travel and as they evolve. So that's an area where we have ongoing research. Now, in particle interactions, leptons have a separate, what's called lepton charge associated with it. There's an electron lepton number, there's a muon lepton number, and a tau lepton number. So an electron and a neutrino have an electron lepton number of +1, a mu lepton number of 0, and a tau lepton number of 0, saying, yes, it's an electron, not the other two. A muon has 0 electron lepton number, a +1 mu lepton number, and a 0 tau lepton number. And similarly for tau, 0 electron number, 0 muon number, but 1 for the tau lepton number. All of those leptons are all spin 1/2 particles. And they all have antiparticles. So for the antiparticles, they're typically written as the same symbol, E, mu, or tau, but with a charge plus instead of a charge minus. For the antimuons, we put a bar over top of the particle name to signify that it's antimatter. And what happens with the antimatter? All of the lepton numbers flip from positive to negative. And that's something that happens with all antimatter. The numbers flip from positive to negative, except for spin. So, hadrons are material that's made of quarks. And quarks are, as best we can tell, the smallest building blocks in addition to the leptons in the matter that makes up our universe. And hadrons fall into two families. The first are called mesons. And mesons have two quarks. Or really, they have one quark and one antiquark combined together. And mesons have a spin of either 0 or a spin of 1. And there's 6 quarks, so at most you'd think there could be 36 combinations. However, as best we can tell, top quark seems too unstable to actually form any interactions, so that means any combination of up, down, charm, strange, and bottom quark with anti-bottom, anti-strange, anti-charm, anti-up, and anti-down quark should all be able to combine to form a meson that's been observed. Now, if you have 3 quarks, you have a baryon. And if you have 3 antiquarks, you have an antibaryon. Now, baryons have some additional charges that also have conservation rules. Baryon number is conserved, so the number of baryons has to remain constant, or the number of antibaryons. Now, strangeness and charm are conserved in the electromagnetic force interaction and the strong force interaction. But strange particles and charm particles can decay under reactions that are governed by the weak force. So it's a kind of weird conservation where sometimes it has to hold, other times it's okay if it's violated. So as best we can tell, this framework seems to be the underpinnings of the ordinary matter that we see in the universe, our standard model. Thanks for watching.